So this is the 44th session on relative velocity. 44th session on relative velocity. So in this again I'll take up a problem on case 1 of the relative velocity problems for mutually translating frames. So before going to session 44, you must definitely consult the session 42nd video on relative velocity before seeing this one, okay? So that you know what is case 1, case 2, case 3 and case 4. So as I just mentioned just now, I am going to take up one more problem on case 1 of mutually translating frames, okay? I'll write down the question here. I'll write down the question, fine. The windscreen of a Jeep, the vertical windscreen of a Jeep consists of two parts, A and B. Upper part A of the Jeep has a height of 25 centimeter and covers the top 5 centimeter of lower part B and covers the top 5 centimeter of lower part B and covers the top 5 centimeter of lower part B. The Jeep moves at a constant speed of 60 km per hour with respect to ground towards right. Raindrops are falling downward vertically downward at a constant speed of 20 km per hour with respect to ground. The Jeep moves in the horizontal direction, okay? Question is, through what maximum possible angle theta can the part A be rotated about the hood axis so that raindrops do not enter the Jeep. Raindrops do not enter the Jeep. This is the question. All right, fine. Now I'll have it, okay? So now, first what I'll do, I'll draw the diagram, okay? Just let me rub it. So I'll draw the diagram, alright. First I'll draw the diagram of the situation. I'll draw the side view, left hand view, okay. So this is the side view of the Jeep. I'm not drawing the complete Jeep, only the relevant part I'm drawing, okay. This is the left side of the Jeep, this is the part A. This is the hood axis, this is the axis of hood, okay. This is the this is part B, and this part is here to here, it is part A. This is part A, 25 centimeter. This is part A. This much is part B. This length is given to be 5 centimeter. This is the bonnet of the Jeep, bonnet. I hope you understand bonnet. Bonnet means all the covering in which all the machine of the Jeep is placed, engine, etc. etc. So this Jeep is going rightward at a constant speed of 60 km per hour with respect to ground, and raindrops are falling vertically downward at a speed of 20 km per hour with respect to ground. Alright, fine. Now, first of all, we identify the frames, or we identify the object under consideration. Object under consideration, raindrop. Object under consideration is what? Raindrop, which is denoted by R. Then for the intermediate frame M, we have the Jeep, which is denoted by J say. And for frame F, we have ground, which is denoted by G say, G for ground. Now what do? We write down the formula for translating frame, velocity relation between two mutual translating frames. So VRG is equal to VRJ plus VJG. J for Jeep, R for raindrop, G for ground. Now for VJG, complete information is given 60 km per hour rightward. VRG also complete information is given 20 km per hour downward. And for VRJ, nothing is known, neither magnitude nor direction. Fine. Now what to be done? This I am saying, this one I am repeating. This is the axis. This is the hood of the Jeep cover, or upper cover of the Jeep, and this is the hood axis, and this is the hood of the Jeep. Alright. So now what to do first now? First of all, again see, it's definitely a problem of case 1. This is known, this is known, this is nothing is known. It's therefore a problem of case 1. Case 1 problem it is. Fine. It's a problem of case 1. Alright. It's a case 1 problem. Alright. So now what to do next? What to be done next? First of all, what we do? We find this VRJ first. Okay. So we solve this for VRJ. VRJ is equal to VRG minus VJG. That is same as VRG plus minus of VJG. So we have to add these two vectors. So VRG is downward 20 km per hour. This is VRG. VJG is 60 rightward. Minus VJG will be 60 leftward. So we parallelogram law we apply. For this we make the tails of these two vectors coincident. So this is minus VJG, that is 60 km per hour left. Now using these two as adjacent sides, we complete the rectangle. Now the diagonal of this parallelogram through the common tail of these two vectors, this is the vector VRJ. This suppose makes an angle of say phi with the rightward horizontal. So this is 20, this is 60. This is 60, this is also 60. This right angle to 60 km per hour. So this right angle triangle, tan phi is this by this. Tan phi is 20 by 60, that is 1 by 3. Tan phi becomes 1 by 3. This is tan phi. So tan phi is equal to 1 by 3, that is equal to tan phi. Fine. Tan phi is just equal to 1 by 3. Now what to be done next? That is the question. So now I'll rub it, okay? So as seen by the person in the jeep, raindrop will appear to come something like this, at an angle of 5 to the right of with the rightward horizontal, at an angle of 5 with the rightward horizontal. The tan phi is equal to 1 by 3 as I said just now. Okay. So see, now I'll rub this. Okay, this I'll rub. See, so raindrop is coming like this, something like this. This is the VRJ, velocity of raindrop with respect to jeep. It makes an angle of 5 with the downward rightward horizontal. Okay, tan phi is 1 by 3. All right. It's like this. See. See this one. See. So now, and there's one raindrop which is coming in this direction, just at the upper part B, uppermost point of part B. This part B. There will be one raindrop will be coming, which will be coming like this. See, raindrop. There's not one raindrop. There are many raindrops. Okay. There will be one raindrop. Raindrop which will be coming like this, and will be hitting just the point on screen A adjacent to the topmost point of part B here. Okay. Now what we do, we begin to rotate this upper windscreen, upper part A about this hood axis. So suppose we rotate it like this. Now what will happen? Raindrop coming on this portion cannot go ahead. That is, this will stop it. Raindrop coming to lowest point of this will come here. It will hit somewhere here. This also cannot enter. So there is one raindrop which will be coming like this. Like this. There is one raindrop which is coming like this. See, like this. This also cannot come inside. Now suppose what we do, we open it still more. Like this. Now raindrop which comes from this cannot go that side because the windscreen will stop it. So raindrop which comes to the lowest point of this, like this will come here and hit it somewhere here. This also part B will stop it. It will not allow to enter it. So now I turn it still further. Raindrop which falls on this cannot enter inside. This will stop it. There will be one raindrop which comes to the lowest point of this. It just passes here. This also comes till here. Part B will stop it. Cannot enter it. Now there will be one angle theta such that windscreen has turned through this angle theta, such that the raindrop which is coming to the lowest point of this windscreen just reaches the top of this part B. So this raindrop still cannot enter beyond it. But if you rotate this windscreen by even by slightly more angle than theta, even by slightly small amount, you rotate from this to this, then what will happen? If you make it here like this, see, like this till here, then from this part raindrop will go like this, and this will enter. Okay. So maximum theta corresponds to which situation? Maximum theta corresponds to that situation in which raindrop passing through the lowest point of part A just hits the uppermost point of part B. Then raindrop cannot, that is the maximum theta. If you rotated the part A even by slightly more amount, then raindrop will enter the jeep because it will pass through the uppermost point of part B. So there is nothing to stop it. Raindrop will come inside the jeep. This corresponds to maximum theta. Okay. So maximum theta corresponds to the case when maximum theta corresponds to the case when raindrop through the lowest point of the part A just passes through the uppermost point of part B. Uppermost point, part B. If you rotate part A even by slightly more amount than this, then there will be some space left between these two directions. Between this one and this one, there will be some space left. Raindrop will come inside the jeep. That corresponds to maximum theta. Okay, that maximum theta we have to find. All right. This I'll grab it. Okay. So now we have to determine that theta. Fine. So I'll just redraw the relevant portion of diagram again like this. This is theta. Okay. This one is 25 centimeter. Okay. Like this. This is the topmost point of part B. Topmost point of part B, this one. And this angle is phi, where tan phi is 1 by 3. This is the direction of VRJ. Velocity of raindrop as seen by G, VRJ. Okay. This is phi. This is theta. And this length is how much? 25 phi. This is 20 centimeter. Because this point is just this point. This point is the highest point of part B. This is 25, this is 5, so this becomes 20. So now we complete this. This is 25. This is right angle. So this length becomes how much? 25 sine theta. This length is 20, this is 25 cos theta. So this length becomes how much? 20 minus 25 cos theta. 20 minus 25 cos theta is this much. This is phi, this is also phi. This is a right angle triangle. This by this equal to tan phi. Tan phi has been found to be 1 by 3. This is equal to this by this. 20 minus 25 cos theta by 25 sin theta. Fine. So from this you can solve this equation in theta. This is a trigonometric equation in theta. On solving this, theta roughly comes out to be around 59 degree. This will be the required answer. Okay. I hope it is clear. So theta comes out roughly to be equal to how much? 59 degrees is the required value of theta. Alright, fine. This also I'll grab it, okay? So now in this video, I'll take up one more question, okay? Fine. I'll take up one more question on case 1 in this video, okay? I'll write down the question. Raindrops are falling vertically downward at a speed of 6 km per hour with respect to ground. A man holding an umbrella walks up an inclined plane. Walks up an inclined plane. Which makes an angle of 30 degree with the rightward horizontal. At a constant speed of 4 km per hour with respect to ground, that is G. 4 km per hour with respect to ground. Okay. We have to find two things. First, speed of raindrop as in a person. With respect to man. And second, at what angle with the downward vertical, should person hold the umbrella axis. So that protects himself from raindrop. In best possible way. All right, fine. So these are two things which have to be answered. All right. Now grab it, okay? So I'll write on the details. Object under consideration is raindrop, denoted by R. Frame M, it is man, denoted by M. Or frame F, which is ground, denoted by G. Again write down the vector equation. VRG is equal to VRM plus VMG. Velocity of man with respect to ground is given. 4 km up the inclined plane, magnitude direction both known. VRG also known, 6 km per hour in downward direction, complete information known. Nothing known about VRM. Again, it's a problem of case 1. So we have to find the magnitude of VRM, and second the angle which the umbrella should be aligned at with vertical. So for this, what we do? We draw the vector diagram. So we solve this for VRM. VRM becomes VRG minus what? VMG. Okay, alright. This will be written as VRG plus minus of what? VMG. This becomes VRM. Alright. VRG and minus VMG vectors of these two. Now I draw the vector diagram. See, VRG is given to be in downward direction. It is given to be downward direction VRG 6 km per hour. Now VMG is what? 4 km per hour up the incline. Minus VMG is reverse of VMG 4 km per hour down the incline. So this is the vector VMG minus VMG. This is equal to 4 km per hour. Okay, and this is the horizontal. This is 30 degree. VMG is in this direction, 30 degree. So this will also be how much? 30 degree. This will also be 30 degree. Okay. So this is equal to minus of VMG. This is the VRG. Now what we have to do with these two adjacent sides, we complete the parallelogram. Okay. Now with these two common diagonal of this parallelogram through the common tail of these two vectors, this vector C, this is the VRM. Okay, all right. Now how to find this VRM is the question. So now see one thing you must see. This is 30 degree. Okay, this is 90 degree. So this is how much? 60 degree by trigonometry. So angle between these two vectors is 60 degree. All right. So VRM is the vectors of these two velocities, that is VRM. That is equal to root under 4 square plus 6 square 2 into 4 into 6 into cos of 60, that is just half. Is it clear? Is it clear what I have said? So VRM becomes, this is 36 plus 16 plus 36, that is 52, and 2 to cancel plus 24, root 76 km per hour. This is the answer to the first part of the question. Fine. Alright. This is the answer to the first part of the question. Speed of raindrop as seen by the person will be root 76 km per hour. Alright. The speed of raindrop as seen by person will be equal to root under 76 km per hour. Alright. One answer has been obtained. Now second is that at what angle with the upward vertical should the person hold the umbrella axis so as to protect himself from the raindrop in the best possible way. Now as I stated for this class of problems in case 2 phase 2 previous video, I clearly mentioned that the umbrella should be aligned along direction of VRM so as to protect himself from the raindrop in the best possible way. So this VRM suppose makes an angle of say theta with the downward vertical. This theta we have to know. Alright. Now how to find theta, that is the question. So what we do now, we extend it downward. Okay. We extend it like this. So this is 4. This is also how much? 4. This is 60 degree. This is also 60 degree. Okay. So now tan theta, you can consider this triangle, this one. Tan theta is equal to this by this. So tan theta is equal to this side by this side. Now this side is how much? This is 4. This is 60 degree. This is also a right angle triangle. This is hypotenuse 4, 60 degree. This becomes 4 sine 60 degree. That is 4 root 3 by 2. That is 2 root 3 by this side. This side is equal to this side plus this side. Is it clear what I have said? We have tan theta is equal to this side by this side. Okay. Now we have to find this side length. This side length we have to find out. Now how to find this side length? This is how much? 6. This is 4. This is cos 60 degree. So this will be how much? This will be how much? Tell me. This will be 4 cos 60 degree. 4 cos 60 is just 2 km per hour because cos 60 degree is half. So this is equal to 6. And this is equal to 4 cos 60, 2. So 6 plus 2, this is 8. So tan theta is equal to 2 root 3 by this plus this. This is equal to 2, this is equal to 6. So 2 plus 6, that is just 8. 2 root 3 by 8. So root 3 by 4. So theta is equal to tan inverse root 3 by 4 is the required answer. Okay. So in order to protect himself from the raindrop in the best possible way, the person should hold the umbrella axis along the direction of VRM, that is at an angle of theta equal to tan inverse root 3 by 4 with a downward vertical. At an angle of theta equal to tan inverse root 3 by 4 with a downward vertical. Okay, this is the answer. So here we have completed the 44th session on relative velocity. Okay. In the next session, I'll take up two more problems on phase 1, then phase 1 will be over. Alright, so now I close it here. Alright.